Arithmetic and geometric sequences. That's what I'm going to discuss in this video. I've listed for you a few arithmetic sequences. Now, when we're looking at arithmetic sequences, the main thing that you're looking for is that your numbers, when they go from one to the next one, they're varying so that we have a constant difference. Our first sequence here, let's just call him sequence number 1. It has as its a sub 1, or its first term, a sub 1 is 1. Its difference, or d, is, well, to go from one term to the next, notice that it always increases by 1, so its difference is 1. For our sequence number 2, our a sub 1 is 1/2, and our difference to go from one term to the next is also 1/2. Now that's just purely coincidence. The A1 and D are not always the same, as you will see in the next sequence. So let's look at sequence number 3. A sub 1, or our very first term, is 6. Our difference is, well, to go from one term to the next, that would be a -2. For sequence number 4, a sub 1 is 5, and our difference is, to go from one term to the next, notice that it always increases by 11. Okay, so those are our arithmetic sequences, our a sub 1, or our first term, and our difference. You will have a constant difference between one term and the next, no matter where you are in this sequence. One of the things that they're going to ask you to do is find an nth term. So let's find, for our sequence number 4, let's say we're going to find the, how about the 8th term? So find 8th term. That would mean our n equals 8. So let's do this for sequence number 4. For sequence number 4, our a sub 1 is 5, our d is 11, and our n is 8. So I would say a sub 8, because that is our n, equals a sub 1 is 5 plus n, which is 8, minus 1 times our difference, which is 11, would equal 5 plus, let's see, that would be 7 times 11, so that would be 77, and our 8th term would be 82. Now, you could always list them out to get your 8th term, but let's say somebody asked you for the 100th term or the 105th term. You really wouldn't want to sit there and count all of those. So this is just an easy formula right here. This is an easy formula to find the nth term. You don't have to have it if they happen to ask you to find, say, the 8th term. I could have just as easily added that up. But it is handy if they ask you to find some term way on out there in the far distance. All right, next thing we're going to do is find the sum of terms, and I'll have to once again know this a1, d, and n in order to get this sum of terms. So we'll talk about what that is. All right, you're given a formula for the sum of a finite arithmetic sequence, and the formula is given right here. Let's say that they asked you for sequence number 4, or look at sequence number 4, and they say, find the sum of the first 8 terms. Find sum of first 8 terms. Now what you will need your n, which is going to be our 8, our a1, which we've already found is 5, and we've already used our d to find our a sub 8, which is our a sub n that we're going to be looking for, and so you'll just plug all those things in and say the sum of the first 8 terms is n, which is 8 over 2 times a1, which is 5, plus a sub n, which is 82. So that's going to be 4 times 87. And let's see, that would be 348. And that's how you're going to find the sum of a finite arithmetic sequence. Now, let's say they gave you an infinite sequence. Because these sequences can go on, you just find the sum up to that point and just look at it as find the sum of the first 8 terms or find the sum of the first 150 terms, whatever it is that they ask you to do. Just use that number of terms as your n, as long as you're starting at the beginning. And you could kind of rig it even if they asked you to start at the middle. If they ask you to start in the middle somewhere, you just use that number as your first term and count up from there. Alright, now just a little snapshot of geometric sequences. I've listed 3 of them here for you, and we'll list them again. 1, 2, and 3. So for sequence number 1, we're going to need to know what the first term is. So for sequence number 1, A1 is 3. And in this case, a geometric sequence is formed by multiplying by a number every single time. So to get the next one, you multiply by whatever. And we're going to call that the ratio, or R. So for this one, 3 times what is 6? That would be 2. 6 times 2 is 12. Does this work all the way across? Yes, it does. So our R in this case would be 2. For our next one, A1 would be 1. And our R would be, let's see, what do I multiply each one by to get the next one? 1 times a half is a half times a half is a fourth times a half is an eighth. Oh yeah, the ratio is 1/2. For our next sequence, A1 is 2, and what do I multiply by to get to the next one? That ratio would be -5. Let's see if it works all the way across. If it does, then we have a geometric sequence. -10 times -5 is +50. +50 times -5 is -250. And once again, I have a geometric sequence. How lovely is that? Alright, now these sequences get big really fast, and they will tend to ask you questions with small n. Now, not always, but they will tend to, because these things get big really fast. So if they ask you for an nth term, they might ask you for, let's see, let's try a 6th term. So let's look at number 1, and let's find the 6th term. That means that n is 6, and I already have, for my formula is sitting right here, I already have my a sub 1 and my r, so I just have to plug these numbers in. It's really helpful if you'll go ahead and figure out what your a sub 1 is, what your ratio is. Just as in the arithmetic sequence, I figured out what A1 was, and I figured out what the distance was before I worked any problem, and it makes your life so much simpler. So a sub 6, my A1, I just look at it, that's 3, times my ratio, which is 2 raised to the 6 minus 1 power. So that would be 3 times 2 to the 5th. To the 5th is 32. So it's 3 times 32, and that's going to be 96. So if I were to look at the 6th term, or to list them off here, if I was to do 48 times 2, which I believe would be my 6th term, so 48 times 2, that would indeed be 96. So you see my formula works for that. So once again, if you figure out your A1, figure out your ratio, then all you have to do is just plug those numbers into a predetermined formula. Alright, I've got the formulas up here for the sum of a finite geometric sequence, which just means find the sum of the first 8 terms, find the sum of the first 20 terms, whatever it is they ask you. Sum of an infinite geometric sequence. Now this would be if you were looking at a sequence that went on and on forever, and you said find the sum of the whole thing if you were to list all of those numbers forever and ever. So I'm going to look at the sum of the infinite geometric sequence. In looking at S of n, well, let's go ahead and do the first one. Let's do sum of the first for number 1. Let's look at sum of the first. Oh, let's see. I wanted to write in green. Sum of the first, we'll say 6 terms. Sum of first 6th. Because we know what they are, and we could add those up and verify that if we wanted to. I know what my a sub 1 is. My a sub 1, I'm looking at sequence number 1 here. A sub 1 is 3, so I've got that out there to the side. I do 1 minus, my ratio is r, that would be 2, raised to the 6. My n, if they say first 6 terms, that's what your n is. All over, and that would be 1 minus my r, and my r is 2. So I would write 1 minus 2. So I'm going to have, let's see if I have room here, 3, and I'll just erase it when I'm finished. 1 minus, and 2 to the 6 would be 64, I think, over 1 minus 2, that would be negative 1. And so this would be negative 63 over negative 1 would be positive 63, so it would be 3 times 63, so that would be 189. So if you were to add up on sequence number 1 the first 6 terms, that means 3 plus 6 plus 12 plus 24 plus 48 plus 96 that we calculated earlier, you would get 189. For this next sequence, I'm going to use sequence number 2. It's the one that would make the most sense for. They'll ask you to actually find the sum of an infinite geometric sequence of something like number 2. See how it keeps getting smaller and smaller and smaller and smaller? You will actually get a value that if you were to add up 1 plus a half plus a fourth plus an 8th plus a 16th plus a 32nd plus a 64th plus blah, 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 and you go on and on and on, and you add up all of those infinite numbers, you will get a value. Let's figure out what that value would be for sequence number 2. So I'm going to do this for sequence number 2 here. My A1 is 1, so I got 1 over 1 minus, and my R is 1/2. So I have 1 divided by 1 minus a half is a half, and 1 divided by a half is 2. So if you were to add up all these numbers, you would actually get 2. And that would be your sum of an infinite geometric sequence.